In this cutaway view of an electric motor, we see the intricate internal engineering that powers much of our modern world. At its core, an electric motor is a device designed to convert electrical energy into mechanical energy through the interaction of magnetic fields and current-carrying conductors. This specific model is a classic example of an induction motor, often referred to as the workhorse of the industry because of its durability and simple design. Starting from the outside, we see the rugged outer frame, usually made of cast iron or aluminum, which features prominent cooling fins. These fins are essential because as the motor operates, electrical resistance in the internal wires generates significant heat. By increasing the surface area, the frame allows heat to dissipate more efficiently into the surrounding air. To further assist with cooling, notice the red fan blades at the rear of the motor. These are attached to the main shaft and spin at high speed, pulling air across the internal components and through the external fins to prevent the motor from overheating during heavy use. The stationary part of the motor, known as the stator, is visible just inside the casing. It consists of a series of copper wire coils, called windings, wrapped around a core made of thin steel laminations. When alternating current flows through these windings, it creates a rotating magnetic field that travels around the inside of the stator. This invisible force is the engine that drives the motor without any physical contact between the stationary and moving parts. In the center of the motor is the rotor, the rotating component that does the actual work. In this squirrel cage design, the rotor consists of a cylinder made of steel laminations with aluminum or copper bars embedded along its length. The rotating magnetic field from the stator induces an electric current within these bars, which in turn creates its own magnetic field. The interaction between the stator's magnetic field and the rotor's magnetic field generates a powerful torque, forcing the rotor to spin. The rotor is mounted on a heavy-duty steel shaft, which extends out of the front of the motor. This shaft is what connects to a pump, a fan, a conveyor belt, or any other machine that needs to be turned. To ensure the shaft spins smoothly with minimal friction, it is supported by high-quality ball bearings at both ends. These bearings are precision-engineered to handle the mechanical stresses of high-speed rotation for thousands of hours of operation. Every detail in this motor, from the insulation on the copper wires to the precision of the bearings, is designed for reliability. This cutaway reveals the hidden complexity of a machine we often take for granted, showing how invisible magnetic forces are harnessed to drive everything from small household appliances to massive industrial factory lines.